So this video lesson is all about rates, which is related to the idea of ratios. So if you haven't watched the ratios lesson yet, make sure you have gone back and done that first before you watch rates. And so just like the ratios lesson, we're going to start off with trying to come up with a definition of what is a rate and then extend it to an idea called unit rates. And so a rate is very much related to a ratio in that it is in fact a ratio, but it's between numbers of different units. And so what does that mean? Well, more often than not, a rate is a change over time. It doesn't have to be a change over time, but often a rate is. So we have the idea of 24 miles in 1 hour. Now we're comparing a distance traveled to an amount of time. And by doing that, we're able to tell how far this, perhaps person, perhaps animal moves in 1 hour. 11 gallons to 30 seconds. Perhaps we're finding out here the rate at which a bucket of water fills up. Or we're looking at 98 meters in 20 minutes. Again, a motion, a kind of change in distance over time. But the key here is to recognize that within each of these rates, we are comparing one type of unit, a distance or a measurement, to a different type of unit. In this example, all of these are compared to time. And so just like ratios, rates can be changed through equivalent rates. We can divide perhaps 11 gallons in 30 seconds by 2 to make 5.5 gallons in 15 seconds. Divide it by 5 and we have 1.1 gallons in 3 seconds. We could even, if we wanted to, divide it even further and get 1.1 divided by 3, that is 1 1/10, times 1/3, 11/10 times 1/3 is 11/30 of a gallon per 1 second. And this idea of 1 second, which is a very interesting case because now we can find out how much water travels into this bucket at 11 gallons in 30 seconds for pretty much any amount of time that we want, because we now have it down to its simplest unit, 1 second. In 24 miles to an hour, we have this down to its simplest unit of change, 24 miles per 1 hour. 98 meters in 20 minutes, if we divided both by 20, we could end up with a meters per minute comparison, per 1 minute. And that is a special type of rate called a unit rate. More often than not, when we have a rate, we want to convert it to a unit rate if we want to use it in any way, shape, or form. And so a unit rate really is just a rate where the denominator value, because rates are most often represented as fractions, where the denominator value is 1 hour. In the other example, we changed it to 1 second by dividing the top by 30. Divide 98 meters by 20, and you have and the denominator by 22, because since it is a ratio, it changes according to the rules of equivalent ratios, just like equivalent rates. Just like equivalent rates that we just talked about. And so that is the idea of a unit rate. And as I mentioned before, the most common type of rate is a change over time, which is something you may have heard before as a rate is another word for speed often when we're talking about things moving. But it doesn't have to be a change over time. You could say that for every 25 miles that you travel, there are 375 trees. Now, that's not a whole lot of trees here, but to give you an example, those two things are related. Now, they have different units. One is a distance, the other is a tree by the side of the road. But if you wanted to compare the amount of trees to the amount of miles, you could say it's 375 trees and 25 miles. You could find a unit rate about that to find the number of trees per mile, which is a very scant 15 in this case. And even though this may seem like a silly comparison to some level, it does illustrate the point that a rate or a unit rate doesn't have to be over time. But more often than anything, these rates are over time. So let's go ahead and look at the next 4 problems. You're going to pause your video as per pause the video as per normal and work on them. And see what you can do in terms of writing the rate itself, which we might call a generic rate, a rate that doesn't necessarily have a 1 in the denominator place if we're talking about it as a fraction, and then transforming that rate into one that is a unit rate. So if we start with number 1, a man drives 375 miles down the road in 6 hours. Well, that comparison is 375 miles in 6 hours. Now, that is our standard rate. If we wanted to change it into a unit rate, we need to make the denominator value into 1. So we divide by 6, because 6 divided by 6 is 1. That means we have to multiply the first value, or divide the first value by 2, rather. 6 divided by 6 is 1. This is now a miles per hour. Might seem as mph. 375 divided by 6, when you go through and you actually do the division, 6 goes into 37 6 times. Left with 15 goes into that twice. And then ends up with a 62.5 miles per hour. For number 2, the idea is that a faucet is leaking 25 gallons of water every 5 minutes. And so we want to find a rate and also a unit rate which describes how many gallons of water are falling out of the faucet in 1 minute. So the standard rate that we want is just comparing the amount of gallons, 25 gallons, to 5 minutes. That is our standard rate. Standard rate or generic rate, I'll use those terms interchangeably. If we want to change it to a unit rate, we need to make this into a rate out of 1 minute. So we divide numerator and denominator by 5 to make 5 minutes into 1 minute. Divide the 25 gallons by 5. We end up with 5 gallons in 1 minute. Now, if you haven't done this so far, it's important as you're finding ratios and rates and unit rates that you do show the transition from a generic specific rate onto a unit rate. That way, if something goes wrong, if you found that you haven't gotten the right unit rate from your generic rate, you can go back somewhere and have a track to find out where did something go wrong. For number 3, a snowflake falls 3,000 feet from the sky in 12 minutes. That comparison, just a generic standard comparison, is comparing 3,000 feet to the falling time, which is 12 minutes. And so to make this into a unit rate, we need to divide numerator and denominator of this fraction form by 12. First and second values. The second value becomes 1 minute, so we can find the amount that the snowflake fell over 1 minute. And 3,000 divided by 12 is 250 feet. So this is now 250 feet per minute. And finally, for an example similar to the one we were talking about before, there are 380 trees on the side of a road over a span of 15 miles. There are 380 trees every 15 miles. So now we want to find out how many trees are there in 1 mile. Well, we have to divide numerator and denominator by 15. First value and second value. In the second value, we end up with 1 mile. And so when we divide 380 by 15, though, we get a bit more of an interesting idea. When we get through the long division, 15 into 38 becomes a 2. 80 into becomes a 3. And then we get to a 5, and that repeats over and over and over as a, excuse me, not as a 23.3, it is a 25.3. So 25 with a 3 repeating, 25 and a third trees every mile. So Again, the idea of a rate is simply just a ratio between numbers with different units, often between numbers in a change over time, but not necessarily. And a unit rate is just a rate in which the denominator value, or the second value, is 1.